Let's take a look at one more example of a nonlinear system. So we have two equations, and at least one of them is not a line. So y equals 6 square root x, and then y equals 7 minus x. That part's a line. The other one is not a line. So if we take a look at that equation, um, it, we could use substitution or elimination here. Anytime that you have both equations set up y equals, okay, because that's a pretty common way to have something, you can actually do a very quick substitution. So if y equals 6 square root x and y equals 7 minus x, well then the right sides of the equation must equal each other, right? Because the left sides are equal. So that's really a use of the transitive property, if you remember that from geometry or something else from previous. But it is a substitution. So we could say this is a substitution for y. So 6 square root x is equal to 7 minus x. Okay, now we have the task of solving this for x when we have a square root x and we have a minus x. That's not, real exciting to me. I'm nervous about that square root x, right? So I'm thinking, let's get rid of that square root x. Let's square both sides, okay? Definitely want those parentheses to be able to square that. Because we're going to need to square the entire both sides of the equation. Okay, but then at least I might have things that are squared, but I won't have square roots. All right, so if I square 6 square root x, I do need to square the 6, that's 36. But then square root of x squared is just x, right? That's really why I was doing that. Now, this side of the equation, 7 minus x squared is equal to 7 minus x times 7 minus x. Okay, I have to FOIL that to get a solution. Okay, so 7 times 7 is 49. The outer is 7 minus times negative x, that's minus 7x. The inner is negative x times 7, and that's minus 7x. And the last term is negative x times negative x, so that's plus x squared. Okay, let's combine all these things and throw them over to the left side of the equation because it looks now like we have a quadratic to solve. I mean, that was really our goal, was to get rid of the square root, but we did end up with a quadratic now. All right, so, oh, actually, I want the x squared over on the right, so I take that back. We're going to throw everything over onto the right side of the equation. So 0 equals x squared minus 14x, just combining these two. And then I have 49, no, sorry, minus 36x. Okay, I forgot that had an x in there, so I'm just going to make one more step. And then plus 49. Okay, so 0 equals x squared minus, what is that, 50x plus 49. Okay, all right, so now we're going to factor. I think this sounds factorable, a weird factoring, right? But I think I'm getting maybe 49 and 1. Unusual, usually it'd be a 7 and 7. So 49 and 1, because if both of those are negative, they'll multiply to be a positive, but they will add to be negative 50. All right, so I have two answers. X is equal to 1 or 49. Okay, so now let's put those answers back in to find y. Okay, so let's see. I have, if x is equal to 1, the y is equal to 6 square root 1. So y is equal to 6. Okay, so my 1 point is 1 comma 6. And if x is equal to 49, then I have y equals 6 square root 49. And square root of 49 is 7, so so y equals 42. Okay, so my other point would be 49 comma 42. Now, the reason that we did this problem is because with this type of system, with nonlinear, you really should check the answer in the other equation. Okay, so let's do that. So if x is equal to 1, we got 1 comma 6. Okay, so we are now going to check, does 1 comma 6 work in equation 2? So that's y equals 7 minus x. Okay, so 6 equals 7 minus 1. Yes, right? That worked. 6 equals 7 minus 1. All right, the other point we have is 49 comma 42. Okay, so if we plug that in, we get 42 equals 7 minus 49. But 42, that 7 minus 49 is negative 42. Nope. Okay, so although we can plug it into one equation and get an answer, we're not getting the same answer from the other equation. Okay, so our only solution, so this is not a solution, and our only solution is 1 comma 6. Okay, so just really do watch out for that. Sometimes I don't check them as much as I should, or I just check them graphically, but you really want to make sure they work in both equations. And then I want to show you the graph because that will support our answer. So here. Okay, so I typed in y equals 6 square root x, and I typed in y equals 7 minus x. Okay, clearly the point 1 comma 6 works, right? Right there, 1 comma 6. But if you'll notice, even if you zoom out, okay, these things are never going to meet again. All right, because our other point was 49 comma 42 or negative 42, right? But this is a line and a parabola. There, I'm out in the hundreds, right? Sorry, not a parabola, a square root graph. So the square root graph only starts at 0 and the y values are only positive, right? The range is 0 to infinity. So it doesn't have that other half of the parabola where it might meet up with the line again. It will never meet up with the line again. So that's why only one of the solutions is right. So do watch out for that in this section.